Any of the future colonies, whether on Mars, on the Moon, on asteroids, or an orbital space station, is going to mean coping with high levels of radiation, extreme temperatures, the lack of oxygen, and the lack of resources in general. On Earth, we have a perfect life support system supplied by a huge and complex biosphere. In space settlements, which are closed and relatively small systems, if we want to ensure a life support system, we will have to recycle or import all the nutrients to avoid its collapse. The closest terrestrial analogy to space life support is possibly that of a nuclear submarine. The challenge of mechanical life support systems in a nuclear submarine is to support humans in closed, small spaces for months without surfacing. This same technology might be employed for space use. Therefore, building a space colony will undoubtedly be one of the biggest challenges humanity has ever faced.
An expedition that's relatively short-lived for science and comes back to Earth, that's a little bit easier. But if you want to sustain civilization on the planet, then you have to figure out how to deal with these issues.
There is, however, still one issue without which we won't be able to survive out there: protection from radiation.
In fact, space is a seething cauldron of very dangerous radiation that comes from two sources. One is galactic cosmic radiation that comes from all directions at once, and the other is solar radiation that comes from the sun.
Cosmic radiation is a hazard. So in low Earth orbit in the International Space Station, we're largely protected by Earth's magnetic field. But as soon as you go to deep space, what's happening is there are particles coming in from the cosmos called galactic cosmic rays, and they go right through the spacecraft walls. And sometimes they collide with them into a shower of other particles, basically protons. And they go right through the flesh, and they can disrupt the DNA.
In environments with no protection to that lethal radiation like the outer space, or the Moon's surface where there is no atmosphere at all, or the surface or Mars with an extremely thin atmosphere, the life would be impossible.
The surface of Mars we've studied in many locations. It's so exposed to radiation and ultraviolet light that even organic molecules are completely destroyed.
Settlements as well as spaceships during the long journey to such distant destinations must be surrounded by sufficient water mass or other materials to absorb most incoming radiation to protect life.
So to protect you for this on a colony, you could have a safe haven. Water, I believe, is a good detector. So if you had a space colony, you could arrange, for there to be either safe rooms or the water storage could be in a strategic location.
In addition to all the challenges we have to overcome to get to our destination, there is one other that we must take into account: the effects of spaceflight on human health. If we want to go to a lunar colony, we would need to travel through space for at least 1 or 2 days with present technology. However, to go to Mars, the journey would take much longer, between 6 and 9 months. Such a long spaceflight would mean very long exposure time to cosmic radiation and to zero gravity, with the subsequent negative effects on human health. In addition to that, a mission of such long duration can carry several psychosocial problems. The solitude that astronauts suffer can generate claustrophobia and depression. In the same way, lack of sleep and monotony may affect the correct performance of tasks that in such a demanding work environment would require extreme precision. Most of the detrimental effects on the human body are related to being exposed to the lack of gravity during long space flights. There are significant adverse effects, which include muscle atrophy and deterioration of the skeleton, which is known as spaceflight osteopenia.
We know that 0G for a considerable length of time doesn't work. You end up with a lot of problems.
The top 3 complaints in space for health are headaches, backaches, and poor sleep. I believe in that order, although it's different for everybody.
Other significant effects, including a slowing of cardiovascular system functions, decreased production of red blood cells, balance disorders, eyesight disorders, and a weakening of the immune system.
You don't have the gravity pulling on your bones, so you'll lose, say, 1% of your femur, your hip bone, every month. Just gets absorbed back by your body because you're not using it as much.
And your bones start losing calcium almost immediately and continue to lose calcium throughout the flight, no matter what the duration is.
So you have several liters of fluid from your lower body that float into your upper body. And if you look at the astronauts on TV, you'll see their faces are rounder than they should be. And that's literally extra fluid that's floated from their legs into their upper body.
These effects happen in zero gravity or microgravity, but on the Moon or Mars, there would be some gravity, so consequences on human health would be different.
So the Moon has 16.6% the gravity of Earth. Mars has roughly 30% the gravity of Earth, 33% the gravity of Earth. We do not know what the human body does with this amount of gravity. We literally have no idea.
Learning to live outside the Earth will be one of humanity's greatest milestones, and it won't be an easy task at all. Engineers and scientists from all over the world are working to develop the technologies that will lead us to be able to establish our first home off Earth.